If you've ever faced just a huge pile of technical documents, manual specs, all that, trying to figure out some complex tech, that
Yeah.
just completely
Right.
overwhelmed. How do you even start to make sense of it without drowning in all the details? Well, today that's exactly what we're going to try and do. We're taking a deep dive into something a bit unexpected. The Dimetra IP Glossary document. Yeah, a glossary. Our mission here is to cut through the jargon, pull out the really important bits, and maybe some surprising nuggets about Motorola's Dimetra IP system. We want to help you understand its core parts, its, global reach, maybe even some features you wouldn't expect. Think of it like getting a peek behind the curtain of a really critical communication system.
It's actually quite remarkable, isn't it? How even a glossary, which, let's be honest, most people think of as pretty dry, just a list of words, it becomes this unique window. What's really revealing here is how much it tells you about the system's basic design, the rules and regulations it has to follow, and even how it's changed over time. It's definitely more than just definitions. It's almost like a blueprint for this intricate digital radio network.
Okay, let's try and unpack this then. For someone hearing about Dimetra IP for the first time, how would you sum up what it is, like at its core?
Right. So at its heart, Dimetra IP is Motorola's, let's call it sophisticated digital radio equipment. It's built specifically to deliver all the benefits of the Tetra standard. And Tetra, that stands for terrestrial trunked radio. It's this widely used digital standard, especially for public safety, emergency services, those mission critical type operations where you need really secure, really reliable comms.
When we talk about its scope, it's not just one little gadget, is it? It sounds like a whole ecosystem.
Exactly, yeah. This system covers, well, everything. From the actual base stations and switches that make up the network backbone to the operations management control centers keeping an eye on it all. And then, of course, the radios people actually use the portables, the units and vehicles, the dispatcher consoles. And it's designed for both private mobile radio PMR and public access mobile radio PMR networks. So it's pretty versatile stuff.
That versatility extends to different versions too, right? I saw mentions of Dimetra IP Compact, Scalable, and Micro or Light TE. What's the main difference there for people listening?
Yeah, that's a really crucial point. These different versions, they speak directly to how flexible the system is, and maybe more importantly, how reliable. See, the compact and scalable versions, they offer options for redundant setups, or even geographically redundant ones, which basically means if one part fails, there's a backup ready to take over. Absolutely critical for, say, emergency services, right? But the Dimetra IP Micro and Dimetra Lite, the document explicitly says they're non-redundant, which, makes you think about where they'd be used. Probably smaller setups, maybe less critical applications where that extra cost of redundancy isn't needed.
Okay, digging deeper into this glossary, something that really jumped out at me wasn't just the tech stuff, but how much it gets into the regulatory side, the legal environment. Like it clearly states Motorola Solutions copyright and reproduction rules. That's not just standard boilerplate, is it?
No, not at all. It really highlights how closely the legal side and the technical side are intertwined for a global product like this. It underlines the huge value of the intellectual property baked into the system. It even kind of raises an interesting question, doesn't it? How much do things like IP rights actually shape or maybe even constrain the technology itself?
And thinking globally, the document talks about compliance beyond just IP. What stood out to you on the environmental regulation front?
Well, connecting this to the bigger picture, you really see a company navigating some complex international environmental rules. Take the EU's WEEE directive, that's waste of electrical and electronic equipment. These products sold in the EU need that crossed out trash bin label.
Hmm.
And that label isn't just decoration, it's telling customers directly, don't throw this in your regular trash, you need to contact your supplier for proper collection. It's a clear signal about responsibility for e-waste.
And it goes beyond Europe, too. It details compliance in China with their management methods or CMM regs. And for those, there are two different logos used. One means, okay, no substances are over the limit. But the second one, that one's interesting. It says the product might have stuff over the limit, but, and this is key, it has an environmental friendly use period, an EFUP. And the example they give is 50 years.
Yeah, that environmental friendly use period, or EFUP, that's quite a concept when you think about product responsibility. It's defined as the time during which any toxic and hazardous substances, TNHS, inside the product won't leak or change in a way that causes pollution or, bodily harm from just using the product. What's really significant here isn't just the 50 years, though that's a long time, it's the shift it represents. It's the company explicitly taking long-term responsibility for the environmental and health impact of its materials. It pushes engineering beyond just how long it works into its whole life cycle, really. And it's also worth noting this specific China disclosure table is only for China. It doesn't cover EU, RoHS, or other global rules, which just shows how fragmented these regulations can be.
Okay, so given all this complexity, the mission-critical nature we've talked about, the global compliance, it really makes you ask, what kind of support system do you need to keep something like this running smoothly? Which leads us right into the support structures mentioned in the glossary.
Indeed. And the document highlights a pretty comprehensive global support network. For example, there's the EMEA Systems Support Center, the ESSC. They provide remote tech support for customers who have active service agreements. And you can reach them via email or phone with specific numbers listed for places like Austria, Germany, the UK, even Saudi Arabia and South Africa. So it shows this broad, reachable support network designed to keep things running for customers all over.
And if something physically breaks, if hardware needs fixing, there's a dedicated place for that too.
Absolutely. For the infrastructure gear, customers would send it to the European Systems Component Center, ESCC, which is in Berlin. And there's a clear process. You have to contact their customer information desk first to get a return material authorization number, an RMA. It's a structured approach, helps streamline the whole repair process and minimize downtime, which is obviously crucial.
Right. And the document also briefly mentions other support channels, like getting parts identified and ordered, either locally or through their online portal, and even support for test equipment. But there was one section that emphasized a different kind of interaction, wasn't there?
It did, yeah. Your input section really stands out. It suggests a company that's actively looking for feedback to make things better, not just broadcasting information one way. It explicitly says comments, corrections, suggestions, ideas are much appreciated, and even gives a specific email address. That points to a commitment to, continuous improvement, using actual user experience to refine the product. It's a good sign for an evolving system.
Speaking of evolving,
Yeah.
what's really fascinating about a document like this glossary is seeing how it changes over time.
Yeah.
That document history section, it's not just dates, is it? It's almost like a mini history of the Dimetra IP sister itself.
Oh, absolutely. It's a fantastic window into how dynamic the product is. You can literally trace its journey from the initial edition back in September 2006, right through to the version listed from May 2012. And along the way, you see terms getting inserted or deleted, things like PDR-RN, GSDR, or AC pop up. RoHS reduction of hazardous substances gets added, and then later terms like SEP and SEPIM disappear. It just clearly shows how new features, changing standards, new tech, they all directly impacted the system's language. The glossary really is a living reflection of the product's development.
Okay, now for the real deep dives part. Let's pull out some of the most intriguing concepts from this glossary. We'll focus on some key areas.
Yeah.
Security, how calls actually work, and how the system operates day to day. These really highlight the clever engineering behind Dimetra IP.
Sounds good. Let's start with security and protection. Foundational stuff here includes the Authentication Center, AUC, and the authentication key, K. You can think of the IUC as the system's gatekeeper, and K as the secret key for each radio. They're used to make sure a mobile station is actually genuine. And the key point, no pun intended, is that a unique key is assigned way back at the factory or some secure facility, so that initial security is built in from the start. Then, layered on top, you've got air interface encryption, AIE, and end-to-end encryption, E2E. The Dimetra system supports these using standard Tetra algorithms, TA1, TE2, TA3. Think of them as different levels of scrambling for the radio waves, plus AES, which is like the gold standard for encrypting data from one end to the other. And for protecting the network itself, there's the Network Interface Barrier, NIB, basically the secure perimeter with firewalls, and the Intrusion Detection System Sensor, IDSS. The IDSS is like a vigilant guard, authenticating users and flagging any potential attacks or weird activity in real time. Now, moving to making calls and communication flow. The call setup time is super important, especially for emergency folks. It's not just one number. It actually varies depending on if it's a group call, a private call, or an interconnect call. It measures the time from hitting that push to talk button to when the first audio comes through or an alert sounds. It shows you the system's precision and how critical that speed is. And what happens if all the channels are busy? Well, the system uses busy handling and busy queuing. So you'll get a busy signal, usually a tone, but your request isn't just dropped. It's held in a busy queue until a channel frees up. Then there's this really interesting difference in how emergency calls get through. Ruthless preemption versus top of queue.
Ruthless preemption. That sounds pretty intense. What's the practical difference there?
It is intense. Ruthless preemption means if an emergency call comes in and needs a channel, the system will immediately terminate an ongoing lower priority call to free up that resource. Just cuts it off. Whereas top of queue is a bit more polite, maybe. It waits for a current call on the channel to finish normally before assigning that channel to the waiting emergency call.
Okay, that's a powerful distinction. So for, let's say, a fire department dealing with a big incident, which one would they likely prioritize and why? That immediate ruthless one or the slightly more patient top of queue?
Oh, for a fire department in a major situation, almost certainly ruthless preemption. In those truly mission-critical scenarios, literally every second can count. Being able to instantly clear a channel, even if it cuts off someone else's non-emergency chat, ensures that critical call gets through without any delay. The trade-off is, yeah, you might interrupt someone, but the absolute priority is life safety.
That makes total sense. Okay, let's shift to mobility and network control. How does a radio actually know where it is and which group it should be talking to as it moves around?
Right, that's where affiliation comes in. That's the process where the mobile station, the radio, basically tells the system, here I am, and these are the groups I'm part of. And this links directly to cell reselection, which is how the radio switches between different coverage areas or cells. There are three main types mentioned: announced, unannounced, and undeclared. The key difference is really about how smooth and fast that handover is. It depends on whether the radio already knows about the new cell it's moving into and what channels are available there. Think of it like your mobile phone seamlessly switching cell towers as you drive, but for these critical radio comms, it shows the intelligence built into managing movement. And for keeping things working even if parts fail, there's local site trunking, LST. This is a crucial fallback. If the main system goes down or maybe a site loses its connection back to the central network, that site can go into LST mode. This means the radios registered at that specific site can keep talking to each other, essentially creating a little communication island. It builds in resilience.
Fascinating stuff. And finally, what about some of the more, let's say, unique features and quality metrics that caught your eye? I saw one term in there that sounded, well, surprising.
Yes, there were a few. Ambience listening, AL, is definitely one that makes you pause. It's described as the ability to listen remotely to audio in the vicinity of a mobile station. Now, yeah, that sounds surprising, and it immediately brings up questions about privacy and ethics, obviously. But in very specific, high-stakes contexts, think police or fire rescue, it could potentially be used for responder safety. Like maybe a supervisor needs to listen in to check if an officer is okay during a dangerous situation without that officer having to actively press their transmit button. So it's a powerful tool, but likely intended for very specific, controlled, critical use cases. Then, for measuring how well everything's working, you have quality of service, QoS. This defines certain characteristics of the connection, like speed, reliability, that are purely down to the network provider's performance. It sets expectations. And a really concrete way to measure that performance is the bit error rate, BERT. This basically characterizes the quality of a digital channel, giving you a hard number to understand how cleanly the data is getting through.
Wow, what a journey through just a glossary. We've gone from the basics of Motorola's Dimetra IP system, test on global compliance, the support network behind it. We saw how the glossary itself evolved, reflecting changes in the tech, and then we really dug into some specific, sophisticated features. Security, call handling, even that ambience listening. It really does show you that even a seemingly dry technical document can hide this rich tapestry of information about a complex, vital communication system.
Absolutely. This whole deep dive into a technical glossary, it's a great reminder, isn't it? That behind every complex system we rely on, there are all these layers of design choices, tough regulations, dedicated human support, all interacting constantly to keep our connected world, well, connected. It really makes you wonder, doesn't it? What other hidden complexities, what other surprising insights are just waiting to be found in the supposedly mundane documents that underpin so much of our modern lives?
That is a fantastic question to leave us with. We really hope this deep dive helps you feel a bit more clued in about these kinds of critical communication systems. And maybe, just maybe, it inspires you to look for those hidden gems in unexpected places yourself. Thank you so much for joining us on this exploration, and we definitely encourage you to keep doing your own deep dives.